So guys, I hope you are still connected to that. So we are just about to start our next session. The next session is about getting started with Oracle 12c Multitenant databases, and the session is being given by Aman Sharma. So before Aman Sharma starts speaking about that, let me introduce Aman Sharma. Aman Sharma is an Oracle database consultant and instructor. He holds a master's degree in computer applications and has been working with Oracle database for over a decade. His main focus is to understand how Oracle database works internally. Beside the core database, he has a very strong knowledge of Linux, Solaris, Oracle RAC, DataGuard, RMAN, Oracle Exadata, and you talk about anything, he would be able to answer you in a masterful way. He is an Oracle certified professional and also an Oracle certified expert in Oracle RAC, SQL, and Linux. He's also an Oracle certified implementation specialist and a certified Solaris system administrator. And that's it about little of the certifications that he has done. In 2010, he was awarded the prestigious Oracle ACE Award from Oracle Corporation. He loves to share his learning with Oracle community. So when he's not delivering an Oracle related session, he spends a lot of his time participating in OTN events, OTN discussions over the web, over the Oracle discussion communities over the web. So he also shares his research and findings over his Oracle blog that he would be sharing in his presentation. He has co-authored two books, Oracle Backup and Recovery, Expert Secrets for Using Arman, and Data Pump from Ramp and Tech Press, and Oracle 12c Backup and Recovery Survival Guide. He is an avid supporter of Oracle User Group and is a member of All India Oracle User Group and is a founder of North India Chapter. So with all this, I would like to introduce Aman to you. So Aman, are you available and can listen to me? Aman, can you hear me?
Yes, Navneet, I can.
Okay, so great to have you on the technical webinar session. So I have already given a brief abstract about your session. So it's all to you now.
Okay, thanks for that. Just give me 1 second.
Sure. So as of now, we can see that funky teddy on your screen. So
Yeah, that's how I look like. Okay, so I hope the screen should be coming up, Navneet.
yes, Aman, I can see the screen right now. Can you also, for a second, just do a simple test by running that in the presentation mode?
Yes, I have just run it in the presentation mode. I'm just going to do it one more time so that we can see it in the presentation mode. Okay.
Oh, great. So I can see that now in the presentation mode. So that should be good now.
Okay, just let me check something. Are we good to go?
Yes, Aman. People are waiting for you now.
Okay, well, thanks a lot, everyone, and thanks a lot, Maneet, for having me here.
Thanks, Aman. All yours now.
Yeah, thanks. Welcome, everyone, to the first webinar of the 2017 from North India chapter. My name is Aman Sharma. As Nareet mentioned, I was a part of starting the North India chapter, regional group in North India. And what she didn't mention, actually, Navneet and Deepak and one more guy, Nikhil, we all four actually started this thing 3 years ago. North India chapter is a regional group. First regional group started by the All India Oracle Users Group, which is actually the parent body for this particular chapter, and many chapters actually now available across India. I'm also a part of the AIOUG, which is the user group on the national level for the Oracle community. About me, very briefly, it's going to be quite some time now that I'm doing Oracle database, about 14 years now. I'm an Oracle ACE, as Navneet mentioned. I'm on the forums with this particular user handle. I serve on the board of All India Oracle User Group as the Director of Special Projects. I am one of the leads in the North India chapter. And yeah, I've got few certifications, and plus I co-authored 2 books, which are on backup and recovery. One is on 11G and one is on 12c. So that aside, the topic that we have for discussion today is about the new feature, or the major feature introduced in terms of 12c, which actually has changed the way how the things are supposed to be done in the future in terms of database management. Is going to be multi-tenant or multi-tenancy. So we're going to see actually that what is actually this particular feature mean. We're going to actually have a look at what are the components, building components of this particular feature. We're also going to look at some of the things which are important to understand in terms of managing these particular components, and we'll have a look at how this is going to be useful in terms of the life of a DBA or a database administrator. So this is a quick recap of what we have in the previous versions. Now, I've just mentioned over here as 11G, but obviously this is going to be applicable to any of the database versions which you have actually come across, at least from the Oracle 7 or 8 onwards. So all of the databases which we have are actually going to be having an instance. An instance, of course, is going to be a set of multiple memory structures. The memory structures are going to be serve with the background processes. So we have got a few of the processes actually running over here. And of course, if it is going to be a database, there is going to be a lot of files that we're going to be having with the database. For example, the redo log files, the archive log files, and of course the table spaces, which are going to be serving the data dictionary as well as the user data. So we have seen, we can actually see over here that we have got the system, sysocs, undo, and few other things actually available to us. And we can also see that the database is having 2 kinds of data. One is the user-specific data, the data which is, of course, belonging to the user. And the second data, which is actually the metadata. The metadata is something which is actually not really directly useful for the user, but it is going to be highly, highly important, because with the metadata itself, the database is able to understand that what exactly the user is doing. So for example, if I have a table, how many blocks, how many extents the table actually has, that is going to be part of the user metadata. And this entire particular thing is going to be, also using the system level information or the system metadata, which is going to be the information about the database itself. So, what exactly the database is containing, the components of database. For example, a very popular package, DBMS output. Now, it's a package which is already built in that is going to be part of the system level information. And of course, this is going to be used by some application. Like in this example, I've tried to put up a sales application. Now, this is something which is going to be created every single time, especially the system level metadata that is going to be created every single time when you're going to be creating a database, which means if I've created like 10 databases on my server, that particular set of 10 databases, they will all have the same system metadata actually created, or I will say recreated, right? And of course, they all will be having the information of the instance and the background processes actually available to them, because that's how databases actually work, or at least they used to work in the previous versions. So this is what we have. So we are going to be having multiple databases. Of course, they're all served with multiple instances. They're all served with multiple background processes, and of course, they all have their own system level metadata and so forth being available. Now the trouble actually is, this is not really something which is very, very effective. And the reason for that is it includes a lot of repetition, a lot of redundancy, which is not really actually supposed to be there. For example, why do we have 2 DB writers? The DB writer is going to be a process which anyway is going to work or going to write onto the particular data files. And it's the same DB writer code which is going to be there on any database which you're going to create, any Oracle database which you're going to create. Which means if you're going to be having, one DB writer, it's going to be serving the purpose same if it's going to be running for one database or even going to be running for more than one database. But the problem is we don't have that kind of functionality available in the previous versions. The second thing is the instance. Now, of course, we do need instance because instance serves as a bridge between the database as well as the user. But we can see over here very clearly that we've got two shared pools, we got two buffer caches, and of course, like this, we've got many such kind of structures actually redundantly created because we're going to be having an individual instance which is going to be there. Now, it doesn't really have a problem as long as you have ample amount of RAM and you have ample amount of hardware resources and so forth. But no matter what kind of resources you have, no matter what kind of system you have, at some time it is going to be actually running out of the hardware or hardware specification, because the more hardware you have, the more you're going to push it, and the more you're going to push it, of course, it's going to run out of the capacity. And not just this kind of architecture is going to be creating one another trouble. Think about this, that how do you actually upgrade these particular databases, or how are you going to patch these databases? Now, if you have like 10 databases on the server and you have to patch them, you can't do the patching just by doing one command and that particular command is going to run across all the systems. That's really not possible, because they're all different databases, right? So that means you have to be actually doing this kind of activity on all the databases one by one, and that takes time. That takes a lot of time, and not to forget that's going to be taking a lot of effort as well, and the redundant effort. You are doing the thing which is already done on one database, and that's going to be actually happening across now multiple databases. Now, that means that this is not really something which is really a good thing. That's what I've tried to put up in this slide, that this kind of, one server running one database with its individual set of resources being used, it is good. It's definitely good. But it is not something which is ideally going to be serving us, good in terms of longer run. Because every database is going to be requiring its own set of individual resources. And resources, of course, can become, less, they become scarce. And by this kind of repetition, by this kind of, a redundant, set of resources being created and being used, we basically are going to be having a trouble that any kind of housekeeping that we're going to be doing on these particular servers, or sorry, these particular databases, is going to be requiring a lot more effort than actually is going to be required for us. So you can see over here that the provisioning, the patching, any kind of housekeeping that we create is going to be a big trouble. I'll not say trouble in terms of doing it, but it's going to be more of a hassle, because now you're doing it in terms of multiple things one by one, again and again, and depending upon how many databases you have, it's going to end up in a very long process, a process which could be actually taken care of. Now, to illustrate that, what exactly we are trying to figure out and what exactly is the problem, we've got a small analogy over here. The analogy actually starts with that let's suppose we have to go for we have to go for a vacation, and we have to go from a place A to place B. Now, if you have to go from place A to place B, what exactly is going to be required, like for the commute? Like, we have got two kinds of communication methods over here. Now, we've got a car, we've got a train, and deliberately we have got a very good car over here. So I've tried to put up a Porsche over here, which is, of course, a very fancy and a very expensive car. But depending upon the choice, someone can pick up the car, someone can pick up the train. Now, if you pick up the car, of course, the comfort is more, the luxury is more, and you might say that the privacy is more. But what about the wear and tear of the engines? What about the fuel consumption? That's going to be, n times over here. So we've got 3 cars over here. That means that's going to be 3 times consumption of fuel that we're actually going to be having. And mind it, we are all going, in this particular example, from this one place A to place B, and we're all going together. So it's really not going to be something which is very economical. It needs more management, redundant management. It needs more of the cost. which is actually going to be taken well care of in terms of using a train. If you're using a train, as you can see over here, a train will be having one engine, which means the wear and tear is going to be only on one side. The fuel consumption is going to be only on one side, and the rest of the things are just going to be the compartments, which means by having the particular redundancy of the engine, the fuel consumption reduced to just one, the train will actually serve us much, much better. Now, this can be illustrated by another example. If you have, for example, to create a house for let's suppose two house owners, or two members of the family, you actually have got two options. You can actually build them an individual house, and they can all be in their own individual houses. But that's going to be requiring a lot of redundant work. You have to first of all build two separate houses, then you have to plug into those particular houses individual electricity supply, water supply, internet supply, and so forth. Or you could do this in a different way. You can actually make one big house, and you can actually have two different rooms or portions allocated from that particular house to those particular family members. Now, with the same one single electricity supply, one single power supply, one single water supply, they can survive very well, and you don't have to manage the cleaning, the whitewash and such kind of things twice, because now you got a single house to manage. And that's exactly what do we have in terms of 11G and 12C. So the C actually in the 12C is basically meant for the consolidation, or the consolidation of the databases in one of the database. So the 12C actually is now not really an new release. It has come quite long back now. We are in 2017. It was launched publicly in 2013 June, and at that time it actually came with lots of features, about nearly 500 new features. And of course, one of the major ones was multi-tenancy. So from the grid computing, we moved over to the cloud computing, and with this particular 12C, the pluggables, which are going to be part of multi-tenancy, the feature actually serves a very great bonding, or you can say a bridge between the cloud environments and the users who are going to be using this kind of databases onto the cloud structures. So the multi-tenancy is basically a database which is released for the cloud as well as for the consolidation. Of course, what we are going to be having in this database is a total change in the database architecture. We are going to be having a one big database which is going to be called as a container, and the rest of the databases are going to be serving as a tenant to that container. Now, this directly compares with my analogy of the house. You can actually have a one big house, and then you can have multiple tenants in the house sharing different rooms, and of course they can have their own privacy in their particular rooms, and that's what exactly is the multi-tenancy feature is all about. Now, of course, being tenants, that means they will not have their own individual, water supply or power supply. They will be actually sharing that from the house. In the same way, the tenants or the pluggables in the container database are going to share the SGAs, the background processes, and such kind of things in the system. And of course, what is the benefit? The things which we discussed before, this kind of architecture is going to serve us much, much better because, it's going to be actually having the reduced requirement for the usage in terms of resources. Of course, it's going to be much easier to manage. For example, if I upgrade a particular database, one single container database, I'm automatically going to upgrade all the individual PDBs inside the database as well, which means it's going to be a much, much faster, or you can say a faster managed database. And in all of these particular things, there is no compromise on the privacy of the data which is going to be there in any of the PDBs. So PDBs basically are going to work like what we have the term in the Las Vegas, that whatever happens in the Vegas remains in the Vegas. Now that basically means it's the same kind of thing which we have in the previous versions in the schemas. If you do something in one schema, of course, as long as you don't really have the privilege to go to that particular schema by the schema owner, you can't do anything in that schema, not even to view any objects in that particular schema. And the same is going to be applicable to a PDB. So PDBs are going to be independent or individual silos, which means anything which is going to be happening in one PDB is going to stick in that one PDB only, which means just like the Las Vegas, you can possibly remember, whatever happens in one PDB remains in one PDB. So there is no such thing, or there is no such worry that having a PDB structure created, it's going to be any kind of compromise that you might have to suffer from, the data privacy being compromised. Now, of course, this is supported on databases like RAC or DataGuard. Definitely, you have the options to manage it graphically as well. So the graphical control, Cloud Control 12c, the Cloud Control 13c, they're all going to be a part of it. There is a new way to actually manage the databases, which is from 12c onwards available. Previously, we had something called database control, but the database control is now replaced by something called EM Express, which is actually a little bit stripped down version of the features, from the database control, but it's a much faster, version available, because this is going to be running from within the database itself. It's using the concept of the application express. So it is basically going to be running, not going to be requiring any kind of agent to be running or any kind of agent to be managed. It's going to be running within the database. So it's much faster. And the SQL developer is going to be another option, which is going to be a very good option to go ahead and use the multi-tenant databases, not just use, but even to manage them. So SQL developer is now having the full capability, not just to manage, but to use, to administer the SQL developer, or sorry, these multi-tenant databases. Now, the administration part is going to be also including the resource manager, which is enhanced also in terms of 12c, both in 12.1 and 12.2, in terms of the management for the PDBs and CDBs. Of course, you must be aware about the resource manager. The resource manager is going to be a management technique to actually manage the resources within the CDBs and PDBs, which is basically to handle the parallelism and such kind of things. And that is going to be applicable in both at the both CDB level as well as at the PDB level. There are two enhancements done in the 12.2, which we'll see very briefly in terms of the in the end of the particular presentation. So what exactly do we have now in terms of the 12c? Well, the 12c starts from the same structure that we have in the basic version, in the previous version of database, which is the previous version like 11g. So we'll have the same thing like an instance, which is going to be a CDB instance now. The CDB instance is going to be an instance which is going to be available now for all the PDBs and CDBs put together, which means you don't really need to create multiple instances just because you got multiple PDBs available to you in terms of the system. The CDB instance is going to be having the memory allocated for CDB, that means the container database, of course, as well as for the PDBs as well. And it is going to manage the parameters as well in case you're going to change them from the PDB level. Now, besides the instance on the disk level, or you can say on the hardware side, we'll be having a container created, which is going to be called as a root container. What exactly the root container contains and what it does, we'll talk about it just in a minute. The second container that we're going to be having is going to be a seed container. The seed container is another container given to us by default, or you can say it's a pluggable database. It's going to be given to us by default by the Oracle, and these two are going to be available to us, anytime when we're going to be having a CDB database created. Besides this, of course, we'll be having our own databases also available. So you can see in this example, we are creating 3 databases: sales, HR, and finance. And they all are going to be hosted by one single CDB database, which is having a new identification introduced from 12.1 called container ID. So you can see actually over here, the container ID or the con_ID is a new identification. It is just like, you can do show user the same way you can do show con ID. So you can see the con ID is shown to you as 0 over here, which is actually meant for the entire container database. And then we have the con ID equal to 1 and 2 assigned to root and seed. This is hard-coded, and that means it is a very good way to identify that in which container you're currently sitting or currently working in. If the con ID is anytime less than or equal to 2, that means you're in a system-defined container. But if it is going to be more than 2, that means you're going to be in a user-defined container or a pluggable, which is currently in the system for sales, HR, and finance. Now, Of course, these two containers are by default available. There is a new view available to you for finding it out that, which particular containers you've got. So you can see that the view name is $containers. Now, the CDB instance, as we actually have seen already, is going to be an instance allocated for the CDB database as well as for the PDBs, which are going to be a part of the CDB. Of course, being a DBA, you just have to manage one CDB instance. You don't really need to create instances, for individual PDBs. But there is an option available to you that you can change the parameters at the PDB level, provided they are actually changeable from the PDB. So, in case you actually change a parameter from the PDB, there's an internal table which Oracle actually uses, to maintain the PDB level parameter information or management of the PDB level parameter changes, which is called PDB underscore SP file dollar. There is no PDB specific SP file or P file which is actually going to be required or even available, for the DBAs. Of course, for a CDB, just like we previously had an SP file or P file possible, we definitely still have available, at the 12.1 or to 12c level. Any parameter changes which you do, like I said previously, at terms of one PDB, they will stick to one PDB. They will not actually be going beyond that particular PDB, which means that particular parameter change is still going to be affecting just the PDB in which the parameter is actually being changed. Now, the CDB instance is something which is going to be required in order to be managed by the same user like sys, which we have already in the previous previous versions. Now, the root container, which is actually a system-defined container, is going to be having a default name, or you can see a pre-default name given to it called CDB $root. Now, the CDB $root or the root container is basically going to be a container which actually hosts those things which we previously had, available to us or created for us as like the system level, information or system level structure. So in a root container, they're going to be having the system metadata. Now you can actually see it is containing those objects which are not really directly useful for a user or even as a matter of fact for the DBA. So you can see that you got obj $, tab $, user $, just for the illustration purpose, but almost all such kind of things available over here, which are going to be very important in terms of managing the database, but are not really important or not even recommended to be accessed directly by a user. Now, this system level metadata in terms of 12c, rather than actually being recreated every single time when a database is going to be created, is going to be available to you just for once, which means you just need to create these obj $, tab $, any such system level metadata information for once. And for the rest of the databases which you're going to be having, the PDBs and such, this information is going to get updated automatically by the system. Now, being a root container, this is going to be hosting those files or table spaces as well, which we previously used to manage. Now, you can see in this example, we have the log files, we have the control files, we have the system, sysocs, undo, the flashback log, backups, and so forth available. And these informations are going to be now shared across with the rest of the databases which are going to be created, which means the PDBs which are going to be created. Now, this is going to be actually the illustration of the CDB $root. So it's the first tenant that you're going to be actually having. Of course, it is going to be containing the system level information, and it is going to be hosting something called the common users. Now, the common users is a new type of the users which we are going to be having now from the 12c onwards. The common users are those users which are going to be available to us commonly across all the containers. Now, what does it mean actually? If you're going to be having a user created as a common user, that user is basically going to be present not just in that container, but in all the containers of your 12c database. We are going to see that, how we're going to create such users, in a minute. Now, moving on, in terms of this particular, CDB management for the root, of course, it can be managed by rman for the backups. It is going to be almost, managed in the same way as we're going to be managing any normal database in the previous, versions. Now, this is going to be requiring to be managed by a sys kind of user. So we will be having now a new definition of the DBAs possibly available called the CDBA or the container DBAs, which means a DBA which is going to be handling the root container plus, of course, all the PDBs inside, and that DBA is going to be now considered as a container DBA, possibly having the access of the sys user account to manage the particular CDB. Now, of course, we need to create the PDBs, but how do we create them? That's what is going to be answered by the creation of this PDB $seed. The PDB $seed is basically going to be available to us as a default pluggable, which is going to be managed or used in terms of as a template in order to create the PDBs in the future, which means this is going to be a PDB which is going to be not having any kind of other purpose except using this. The DBAs actually can create their own pluggables in the future. Now, this particular pluggable is going to be available to you in terms of the read-only manner, which means this particular PDB is only going to be useful for the purpose that it is going to be having the option of just close and open. It doesn't really have any such kind of thing which is going to be it's going to be affecting the management of the system. Now, the CDBs are going to be having just one seed. There is no requirement for another seed. Of course, it is possible to be taking the backup of it by the RMAN and such kind of things, which means you can definitely going to be having the same kind of structures or the same kind of commands which you use for the normal databases, even to manage the seed. But it is not possible to have it in terms of the read-write manner. And the seed is going to be having the system and sysocs as well as temp, but these table spaces are only going to be useful for the purpose of creating a clone, or you can say creating a new PDB by you in the future. Now, moving on to the next part, that's how we can actually see whether we have our database available to us in terms of the multi-tenant or not. Now, I've already shown the examples over here. So you can actually go to the $V database and you can actually see from there the con ID. And of course, you have a column over there called CDB, which is going to tell you that whether you are a container database or not. Now, you notice actually that if you're going to be having a container ID mentioned, it's going to be mentioned to you as 0 for a database which is going to be created as a container database. You can see that my database name is ACDB, which is representing this, that I will be having this database is representing a container database. And in this container database, I've got multiple pluggables created, which is actually available to me as in terms of the normal pluggable. So if I just try to show it to you, okay, so let's go ahead and try to show the entire thing. Okay, I hope it is going to be visible. So the idea basically is that, let me just check it's visible or not. Okay, I guess it is. Let's go ahead for the entire screen. Okay. So here I am, and let's connect and you can see that this is the same output which I've just shown to you in terms of the in terms of the screen or in terms of my presentation. So basically what we have over here is the output of the $V container actually shown to you, which is basically a very simple command running from the view $V containers. Okay, so moving on. All right, so there we go. All right, so this is what the output we've just shown to you, that we have got the particular structure available to us in terms of the system. Now we can see that in terms of the pluggables, we are going to be having requirement of creating database users. Now, the database users, of course, are going to be requiring to have their own set of data. And that is what exactly where the pluggables or the user-defined pluggables actually come into the picture. So what we can see over here that we have got a root container so far, we've got a seed container so far, and we got a bunch of files and table spaces which are going to be required to manage the system altogether. But now we introduce the user level pluggable. So we can see that we are having a user level pluggable created, which is going to be called sales. And you can see in this sales pluggable, I've got the tables of customers and countries actually available to me. Now, this customers and countries, which is actually available to me, is basically going to be the the container which is currently being available to us. You can see that these two tables, the customers and countries, are the user level tables. Now, their metadata is basically going to be updated in terms of the system or in terms of the container. That means the system will be knowing already about this, that what a PDB is actually having, what the PDB is actually containing, and that information is going to be available to you from, of course, the PDB level and, of course, from the CDB level. And you can notice that we've got individual table spaces, systems, sysocs, sales, as well as the user's table space mentioned over here. And this user level table space which we have created over here is going to be a table space in which we are going to be actually having the particular user level specific information actually to be created, which means you can notice that in the root container, we did not have this users actually created because it is not actually a good idea to use users table space or such kind of table space to be available in the container or the root container, because the root container is not meant to create or manage any kind of user specific data. Any user specific data has to be managed in terms of individually created or a manually created pluggable database. So that is what is going to be there. Now that means, of course, like this, you can have one such kind of PDB or you can have more than one such kind of PDBs actually being available. Now, this is where the particular PDB information is going to be. So PDBs are, of course, going to be possible to get user defined and created. You have to explicitly name them. You have to explicitly manage them. And the PDBs are going to be having the pointers to the root container, which means whatever you do in a PDB, that information is going to be available to the root container as well as to the CDB container. Now that means it is going to be a possibility that you can define your own specific set of data and your own specific set of users in terms of the PDB. That is why a new term, just like we had in terms of CDBs called common users, is also there for the PDBs called local users. The local users are basically the users which are specific to one PDB, which means whatever you do or create by this local user is going to be specific only to that PDB in which you're actually going to be managing it. Now, at the moment in 12.1, you got 253 PDBs available to you, which is basically including the seed as well. But this number has been changed from 12.2, and I will show you the number in the end of the presentation. Now, there are two different kinds of manageability options available to you. You can have a PDB specific administration possible, which is going to be requiring that you create a PDB administrator specifically for the PDB only, which means you don't really need to give the user the access of the sys password just because he has to manage the PDB. You can create a PDB specific user which is going to be considered as a PDB administrator, and of course will be considered as a PDB admin or a PDB DBA, and of course you can manage it through the sys user as well in case you are not having any problem sharing the access of the sys user to the specific users. Now, the PDBs of course can be linked to the other PDBs as well, which is going to be a part of the same way that you manage any of the database links in the previous versions, which is through the DB links. But to manage the PDBs, we've got a different kind of PDB option, or you can say views available, which are going to be $PDBS or DBA PDBS. These views are going to be specific views which are going to be there in terms of the manageability of the PDBs. Now, this is kind of a view which we have got over here. This is kind of representation that how the PDBs and CDBs are going to interact with each other. And it's really not different from the previous slide that we saw. Basically, all the PDBs are supposed to handle the user level information, and the CDBs are actually going to look upon to them. That means the CDBs are actually going to be having the information available, for all the PDBs plus of the CDB as such. So how do you actually go ahead and create the multi-tenant database? Well, of course, you can do it at the time of installation, or you can do it afterwards, like you can do it from the DBCA or from the create database command. Now, if you're doing it from the DBCA, at the moment, speaking of 12.1, you do have an option to specify that your database is possibly going to be a CDB database or a non-CDB database. Now, you do notice there is a checkbox over here mentioned, sorry for that, which is actually saying that do you want to make this database as a container database or not? This is not by default selected, which means you do have an option that you can actually create a database even in 12c as a multi-tenant database. Only when you select this database as a container, you're actually going to be having the option that the database is going to be created as a container database, having the privilege to contain pluggables inside. Mind it, it is definitely possible that you can create a container DB without having a pluggable available, because a pluggable is meant actually for the user level stuff or user level data. If you are not willing to have such kind of information created right now, of course, you can actually leave the PDB creation for the future, and you can just have a CDB, and the root and the seed will be created for you. But the rest of those things you can actually, or the rest of the pluggables you can create later on. In case you want to do the same thing from the create database, it is also the same. It is going to be having the same set of commands or same set of instructions, but some parameters are going to be there, like the enable pluggable database, and you need to actually use another parameter called seed and file name convert if you're not using the Oracle managed files. If in case you're going to be using such kind of information, then of course this kind of parameter, the PDB file name convert or seed file name convert, they're not really going to be required, because OMF is going to handle all the file handling or file creation. So you can see actually that we are going to be having the create database command shown to you, and the create database command is absolutely same except for the enable pluggable database option, which is over here, and you have to mention the keyword seed, which is going to be here, and rest of the things are going to be same. Now you can see that after running this, you do have to mention a script called cat cdb.sql. I have actually mentioned a cross number over here for a MOS note. This number was actually there. It was actually a bug introduced in a bug. It was there in 12.1. This script was not present in 12.1.1, but in 12.1.2, the script is available. So that's why this particular number is now crossed by me, so that you don't really need to actually have any worries about this number is no longer valid. This bug is no longer valid. Now, when you run this command, of course, you can have a database mentioned over here. So what I'm doing actually right now, I'm actually creating a particular specific set of PDBs mentioned in over here. You can see that I mentioned information about the container. I mentioned information about the seed. The seed information. So the PDB seed is going to be there. The information about the data files and so forth. And of course, after that, we'll run the particular cat cdb.sql. Now, once you end up creating a database by either way, you will end up with having one root container, one seed container, and each of these databases are going to end up by actually creating a service inside your particular system. So that means every PDB is going to be running as a service inside your database. And also you'll be ending up with local users and common users and bunch of the views which are going to be new. Now, of course, we have seen some of the views just now, like we have seen $, PDBS, $, container, and so forth. But there are some new set of terminologies created even for the previous views available to us. So let's look at the common and local user part first. The common users, as we mentioned, are those users which are basically going to be there as available to all the containers. Now, because they are going to be considered as common users, there has to be a different way to actually create them. And that is why the common users are going to be appended with the C double hash in capital or C double hash in small. Now, this is actually maintained by an internal parameter. If you don't really want to put this kind of prefix in terms of your username, you definitely can change that internal parameter, which I would not mention over here, because that is going to create quite a lot of confusion that you'll not be able to distinguish that your user is a common user or it's going to be a local user. The common users are must to be created in terms of the root account, which basically means they will be actually available to you in the root container. And of course, being available in the root container, they will be working in the root container plus in all the PDBs inside that container as well. Some default accounts like sys system are automatically going to be available to you as a common user, which means if you make a database, and of course with the database you'll be ending up with a sys user, that sys user account you can actually manage definitely for the container, as well as you can manage it for the particular PDB. And in case you want to manage it, or you want to manage explicitly a user as a common user, you have to use a new keyword, which is now going to be there called container. And you have to mention over here container equal to all, in case the user is supposed to be a part of a common user credential. The container equal to all is only possible if you're going to be working in such a container which can actually look upon the other pluggables as well. On the contrary, the local user is going to be a normal user which you have created already in your previous versions in the databases, which means they do not need any kind of special prefix, but they will be available to you in a specific container in case you want to limit that user to a specific container, or even in case you're going to be doing it from a root, you have to mention the container equal to PDB, the name of the PDB in which the user is going to be created. Now, these users are of course designated for that PDB. That means they cannot look beyond that particular PDB. And I'll show an example to you just in a minute. So like we have got local users and common users, we also have now a discrimination in terms of the user view. So of course, we already know that we're going to be having the user underscore views, which are basically the views for the objects owned by you. We've got the all underscore, which is accessible as well as owned. We've got DBA, of course, we can see, being a DBA or having a DBA role, everything. And on top of that, we've got now the CDB underscore views as well, which means you have the information now, which is going to be available to you from root as well as from the pluggables. You can notice the difference that DB underscore is basically going to be from the container, whichever container you are currently available with, as well as from the pluggables. So here is example that, how can you see this thing that in which container you are right now? You can do this by looking at the con ID. What I have done actually, I've made a small example for that. Let me just see if I can show it to you. So hold on a second. There we go. We'll just wait for the display to come. Hopefully the screen sharing should be coming. Okay, so this is what the view that we have. So what we have done actually, I've actually created a very small example. Who am I? CDB. You can see that what I've done actually, I've got a small package or small block created, which is actually showing to me that where I am. So this is something which I've created just for the sake of demonstration. So who am I? It is not a default package. You can see that who am I CDB is actually showing to me that I am currently the user sys. I'm having so and so session ID. This is the current schema. I'm in the ACDB instance name. I'm in the CDB name of ACDB. I'm in the current root container. And of course, I can check the same thing by using the con ID. As you can see, as I've mentioned to you already, that the con ID represents the particular container in which you are. And in case it is going to be less than 2 or equal to 2 or up till 2, it's going to be a system-defined container. Now, of course, using ID is going to be a little bit troublesome. So we've also got something called the show con name. And you can actually notice the show con name is actually showing to us that we are basically having the root container available to us. And we are currently working in the root container. Now, the root container is basically the container which we have got as a default container. Of course, we don't want to actually manage or you want to actually work in that. So we need to connect to that particular container, which is going to be our own container. So now what I'm doing, I'm connecting to my PDB. So let's check that where we are right now. Who am I? CDB set server output on, and let's do it again. Now you can notice that I am actually shown that the instance name is ACDB and my CDB name is ACDB, but my current container is actually APDB, which is actually my pluggable database name. And we can confirm this thing by looking at the con ID. And you can also notice the con ID is the ID equal to 3. And of course, the con name is actually APDB, which is showing to us that we are basically in the container called APDB, or in the pluggable database called APDB. Now, this should confirm two things to you, that every database which you're going to be actually managing can be managed by the local users or by the system, a common user like system. So I have connected to this pluggable database as like a database. As like a user from sys, and with a particular pluggable database or container database, you can actually confirm wherever you are by looking at the con ID. Now, another thing to be very important to be mentioned is that I need to mention a service or TNS names alias actually to connect to a PDB. I can't just go and connect to a PDB by saying connect as sysdba. So let me just show it to you that what exactly do I mean. If I say con/sysdba, which is a practice that almost every DBA is already very familiar with. So you do connect/sysdba, you basically end up in terms of a database connection. But where are we right now? And if we just check, let's enable the server output on. You do notice you did not connect to a pluggable. You basically are connected to the root container, and you can confirm this thing by my code, or you can even confirm this thing by looking at the container ID. You can see that the container ID is 1, and of course, if we confirm the name, I'm in the root container, which means to actually connect to a PDB. And now let's try to connect to a PDB. All right, so I'm trying to say over here that the APDB is missing. I'm trying to connect over here as sysdba. Do I get connected? Of course I did get connected, but where do I get connected to? I got connected to the root container, which is not where I wanted to be. I wanted to be in the pluggable, and for doing that, the listener must be up. The TNS alias must be present in order to show it to you that in order to connect you to that particular system. So let's try to see. I'm in the tnsnames.ora network admin folder. So let's try to bring up the tnsnames.ora. And you do notice that I have actually the TNS alias mentioned in my particular tnsnames.ora that I want to connect to my system to the APDB or whatever this database is name is going to be. So that means it is going to be very, very important that you must have the tnsnames.ora properly configured in case you want to manage or work in the particular PDB. So now if I do mention SysOracle APDB as sysdba, now I am actually in the APDB or in the current system. So you can see that we are connecting now correctly to the pluggable database. And of course, this pluggable database is mentioned properly. So you can see that I have mentioned over here properly that my system name is going to be what, my service name is going to be what, and of course, my alias name is going to be what. That means for every pluggable that you're going to be managing or want to connect to, you do need to have a proper entry configured in your tnsnames.ora. So going back now, okay, there we go. So that's what we just have seen, that how can we actually switch over to different set of containers. We can actually switch over to the containers by doing the connection, or we can even do the same by doing a command, by using a command called alter session set container equal to apdb. So you can actually do this, like you can see over here. I am connecting to the container database root container first of all by saying acdb as in my connectivity string, and then I'm using alter session set container equal to, and I'm moving on to the pluggable database. Now, of course, it is going to be important from 12c, especially in the multi-tenant option onwards, that you do need to take care that what exactly you're doing and where. So take an example over here that we are connecting to the sysdba, and we're looking at the container ID 1 to confirm that we are actually a part of the root container. Now, I'm doing a query on dba underscore users. The dba underscore users is basically going to be a normal view, of course, that is visible or known to everyone. The db underscore users is going to show me some count of users that I've got in my database so far. So you can see that db underscore users is showing me that there are 36 users available to me right now. But do I get the same information if I go to the CDB users? Of course not. With the CDB underscore users, I get to know a lot more count from DB underscore users. And you can see the DB underscore users is saying 36. On the contrary, the CDB underscore users is showing me 119, a way larger number. But why it is so? Because being in a root container, you can actually look at the root container as well as all the pluggables as well, which means if you go to db underscore users, you can look at that container and see what the container is actually all about, and you can actually see the information of that container. But when you go ahead and look at the same from the cdb underscore users and you connect it to the root, you can actually see the information of the root container plus all the pluggables as well, which are going to be part of that container. Now, is it going to be the same thing if you're going to be connecting to a normal pluggable database, which we have created with the name of apdb? And you can see over here with the apdb as sysdba, if I check out the same like con ID and so forth, I'll get to know that it is more than 2. So this con ID is 3. That means I'm right now in a user-defined pluggable. And if I check out the username information from the db underscore users, I do get to know that this particular count is 48, which is okay. I don't really need to know that, who are the users and what they're actually doing. But what about if I'm going to be selecting the same from cdb underscore users? Now, as I said before, a PDB is going to be an individual private silo. A PDB cannot see beyond its own. That means in a PDB, despite you use CDB underscore users or use DB underscore users, you're going to end up seeing only what the PDB is allowed to see, which means you're going to be you're going to be just able to see 48 from both the views, which is going to confirm the statement that in a PDB, you can only see what the PDB is actually able to do. Now, as I said, all of these PDBs are going to be part of services, which are going to be mentioned in a view CDB underscore services. Currently in 12.1, there are 512 services which are available to you. And you can notice actually that each of this particular PDB which we are creating or CDB which we are creating is going to be ending up in the form of a service. Of course, like the previous versions, we do have the $background and $users still available to us, which are internal services. This is just a query that I put across to show you that what exactly is going on. Not really very important, just to show that which table spaces are going to be part of which particular table space. So how do you really manage these PDBs? How do you really create these PDBs, which is basically going to be a more of a task required to be done by the DBA. So you have different options for that. Of course, you can use SQL commands. You can use SQL Developer for the same. And there is going to be an option to actually do this graphically as well, which is going to be a multi-tenant self-service provisioning application, which is going to be a separately installable application that you need to actually install to manage these things, in terms of doing the management graphically. DBCA is another option to manage the same. So here is some of the commands which you can actually use to manage the PDBs. For example, you can have all the PDBs opened or closed by mentioning the command alter pluggable, or you can actually connect to a particular PDB and you can actually close it. Mind it, the PDBs are going to be opened and closed. You don't really have the option to dismount, or you can say the instance level shutdown for the PDB. That's really not going to be an option, because PDBs are sitting on top of a CDB, which means a CDB definitely has to be present. So all what we can do is we can actually open a PDB, or we can close a PDB, and that's how we are going to be using the command, the open and close. Now there are options to manage the PDB state. Remember the PDB state, and that means you can actually define this thing that if you've got like 40 PDBs in your container, you don't want all 40 to be actually coming up with the container database being open. So from 12.1.2, you have an option called save state, and with the save state, what you can do is you can actually define that, or you can actually make the database remember the PDB's current state when it is going to be next restarted. So if the current PDB state is, for example, shut down, even in the next container startup, it's going to be remaining as shut down. This is going to be requiring that you install 12.1.2, in which this option is going to be available. Of course, this option, the views information is going to be there from $PDBS, which is going to show you the information about the PDBs. A lot of information about them is going to be visible to you from there. Another view, DB_PDBS, is going to be there. And in case you want to manage these PDBs by yourself, there are options available for the same as well. For example, we can actually use the seed container to actually create a PDB. So you can see in this example, we are basically creating a new PDB with the name called APDB CPY, which is actually going to be a copy of the previous pluggable, and we're creating a user for managing it explicitly called Aman. So you can see that we are mentioning that there is a user called Aman, which is going to be the admin user. It's going to be identified by the password, and this particular pluggable is basically going to be created by us from the copy of the PDB seed. Because we're not using OMF, so we are using the file name convert parameter over here. In case I'm using the OMF, such parameter is not going to be actually required. Now, if you do have a PDB already created, your user-defined PDB already created, you can actually copy the new PDB from there as well. So in this example, you can see I'm actually creating a new PDB from APDB, which I'm going to be calling as APDB2. Pretty simple command, create pluggable database from another pluggable. Of course, that is going to be helping you out in order to create a new pluggable more quickly. Now, you can also create a pluggable by unplugging, a PDB. Now, this is something which is going to be required or important depending upon, the manageability factor. For example, I might want to have a particular pluggable supporting a particular version, for example, 12.1. And now my container has to be upgraded to 12.2. But my application, which is currently using the 12.1 PDB, is not yet supporting 12.2. So what I'm going to do, I need to upgrade the container because I need to upgrade the rest of the PDBs to 12.2, but I don't want to upgrade one specific container. So what I can do is I can actually have another CDB created of 12.1, and I can unplug and plug again this PDB into that container. So this is what we're trying to do over here. You can see we are exporting the entire definition of the PDB in an XML file. Of course, we need to keep the the data files of that PDB, because if you don't, the PDB cannot be actually moved into another container. And you can see in the container, I'm going to run the command create pluggable using the XML file with of course the files being present. By this, what I've achieved actually, I have actually made sure that I have unplugged a particular PDB to a different CDB depending upon the version, and then later on, whenever I'm going to be ready to have it converted to 12.2, I can just plug it back to a 12.2 container. Of course, the 12.2 container being upgraded to 12.2 is going to be enough for the PDB also being shifted to 12.2. I don't need to specifically do an upgrade of the PDB explicitly. So this is something which is going to be a very handy feature to manage the version control in terms of the PDBs. Now, in case you're going to be having a non-CDB database created, the non-CDB directly cannot be converted to a CDB database, first of all, which means you really don't have a command available that a non-CDB, which means in 12c, if you made a non-CDB database, you can actually have it converted by some way to a CDB database. The non-CDB has to be actually, inserted into a container in the form of a pluggable. That's what we're trying to do over here. So we are taking the example that we have a database which is a non-CDB database, and it is in 12c, and we're going to export this in form of XML definition with the help of a package called dbms_pdb, and then we're going to create from this definition a new pluggable in one of the 12.1 containers. And you must notice that we're running a script, a new script introduced non-CDB to PDB SQL. This script takes about 15 to 20 minutes of time, irrespective of your hardware. I have actually tried to test it out by having a different set of hardwares to run this script, but the hardware change did not affect the time. So I don't know actually that whether it is possible to tune it further or not, but in terms of my testing on a laptop, on a big server, the time was almost a constant. So I didn't really actually get to find out that if there's a way to actually make it more faster, the script running to be more faster. Of course, there is a new option in 12.2, which is actually to use parallelism to create the PDBs, which is definitely going to be helping out in making a PDB more faster. But for the script, I am not very sure. But if you're going to be in 12.1, now it's going to be a little bit difficult task, because in previous versions like 11G or so, there's no such option to actually have this kind of PDB and CDB thing. So there we have to use the traditional things like data pump or possibly replication, and we have to actually do the export import, for example, of the previous version of database, and then import it into a new pluggable of the 12.1 CDB. How do you drop it? Pretty simple. You can just mention drop pluggable. Of course, before dropping, you can export the definition, and then after that, you can drop the pluggable completely with its files. This is what the SQL developer, which is going to be there. So this is a screenshot that I have taken actually to show that the SQL developer has a specific option to manage the pluggables. So you can see that, the drop pluggable, clone, unplug, modify state, all of this is actually going to be visible to you to manage the pluggables, just like you can do this by the cloud control. Now, this is an application which is the pluggable database self-service application. This is an application which is basically not available by default at the moment, but it is a very handy application which is possibly going to help you out in order to manage these pluggables graphically. For example, you want to create a new pluggable very quickly for your organization, and you don't really want to remember the commands or execute the commands. By this application, you can do this very, very quickly. So this is a set of instructions. Of course, the presentation will be sent, so there's no need actually to remember or go through with these steps all the time. You can actually just look at the presentation and run these steps. So you got a download to be there first of all for this, and then you have to make sure that your Apex version is going to be a specific release 4.2.0, which is going to be there anyways from 12.1. And then you have to actually create or run a couple of things, which is what is shown over here. Run a script called pdbs_ins, which is going to be creating this application for you. And finally, it is going to be running for you on the port number 600. So I've just shown a screenshot to you for this, which I have done. So you can see that I've got a PDB shown to me called ORCL PDB. And in case I want to make a new PDB, you can definitely see that there's an option there called new database, and I can manage my PDBs from here. Sorry, DBCA is going to be another option. So DBCA has a specific section now to manage the pluggables, and you can see that we've got all the options over here: create database, unplug, configure, and so forth for the same. Now, these are some of the options which are there in terms of 12.1.2. You can actually have the state management, for example, like I mentioned to you, that you can save the state, you can discard the state, you can have the remote cloning possible for the PDBs. You can use the PDBs in terms of OMF using create file dest. You can have the PDB tablespace level logging to be actually managed. And there are some new options in 12.2.1 as well. First of all, the number of PDBs are now possible in 12.2 in terms of 4,000, which means compared to 253 in 12.1, in 12.2, you have got 4,096 PDBs possible in one container. You do have an option to create different character sets for PDB. So previously it was not really possible. Previously, the only option which you could have is that the PDBs had to share the character set of the container as well. So now it is really not a kind of thing. You can actually have different character sets possible if you really want to do it. And a very handy thing which is called a proxy DB. The proxy DB is sort of like a kind of bridge which is going to be referring or connecting to a remote PDB. Now this is something which is going to be handy. For example, you want to relocate your PDB, to a different server, but you don't want to change any kind of connection details. You don't want to change anything in your current connection. So what you can do is you can relocate the PDB and make this kind of proxy DB with the same name, with the same location. And of course, it is going to be helping or working as a bridge, to connect to you to that particular remote DB. Or even in terms of the cloud, you may want to create a PDB in the cloud, but you don't want all the users and applications and DBAs actually to have the access to that particular cloud. You basically want to make them a connection to a local PDB, and from there you want to connect them to the cloud. From there you can actually for that purpose you can actually use this particular proxy DB. So this again is only in 12.2. You can relocate a PDB from one CDB to another directly now. As I mentioned, in terms of 12.2, there are enhancements done in terms of the resource management. So now you have a better control what amount of memory, what amount of I/O in terms of PDB level you want to actually control. So this is possibly going to help you out in the way, for example, you don't want that one particular pluggable, for example, if it is consuming like 90% of the memory, from the entire system, and you got like bunch of pluggables actually available to you, so they all will be suffering for this kind of reason. So this is something which is not possible to be controlled in the previous versions, because one bad PDB like this, if you create or if you have, it is going to affect all the other PDB. So now it is possible that the parameters which you can actually have, like DB cache, shared pool, SJ target, and so forth, if it is going to be there, it is actually going to control this thing that you can actually have this kind of restriction now possible, that how much amount of memory a particular PDB is actually going to consume without affecting the other PDBs in the system. Of course, the same thing is going to be there for the disk IO. Mind it, it's only available in 12.2, and 12.2 is not available at the moment for the download. But the release information is mentioned in this Metalink doc. You can see 742060.1. Very, very important. I will very highly recommend you that you should look at this particular doc. This does not really tell you right now even that when you're going to be having the 12.2 available for download, but it will be coming up soon. And it also has information about how the a framework for support is actually going to work right now for 11.204 and for 12.1. So it's a very, very handy note, and it is updated for 12.2.1 as well as for 12.2.2. So more enhancements, like I mentioned to you, you can define the upgrade, for the PDB prioritized. You can actually mention that which PDB you want to actually, go ahead for the upgrade, and you can have the flashback possible now for the PDB level. You can have the parallelization for the PDB available. All of these, new informations are available in the 12.2 documentation, which I've given the link over here. So in case you want to read more about them, you can just go to this particular link, and you can actually check from there, which is definitely available free of cost at docs.oracle.com. So that's pretty much about it. So to sum it up, definitely the multi-tenancy is one of the most major changes that have been introduced in the database in the last few years. This is, of course, not the complete coverage. There are many things in terms of security, in terms of backup, in terms of administration. How do you really go ahead in terms of do the performance management for the PDB? So it's going to be there it's a very large, it's a very detailed topic anyways, which is going to be there. But definitely we can actually have this information more given to you in terms of these links. You can go to this Oracle Learning Library, which is going to be there. The Oracle Learning Library is having a specific link for the particular 12c. So it is definitely having the information about how you can actually manage the PDBs in a more better way, and a lot of information about different features about it. And I think that's pretty much which is there. So that's it. That's where I tweet. That's what my blog is, and that's where my email ID is. In case you have any questions. Okay, so that's pretty much
Yeah,
is the end of the
thanks.
presentation.
Yeah,
Navneet.
thanks, Aman. Thanks, Aman. So it was quite a deep dive into multi-tenancy, and people must have learned a lot. And I have been getting quite a few questions, so
Mm-hmm.
I have a list ready for you.
Yeah.
So I would be going through the questions one by one.
Mm-hmm.
Okay, so to start with, first question is from Krishna, and the
Mm-hmm.
question is: if one of the PDB is consuming 90% of CPU, then it
Mm-hmm.
will affect the performance of other DBs. When
Yeah,
other
it will.
DBs, it's other PDBs, right? So
Yes.
how in 12c performance means how 12c is managing this performance bottleneck?
See, as I mentioned already, that in 12.2 you have two individual controls available, one for the memory and one for the I/O. For the CPU, at the moment, it is not pretty much there. It is something which is still, you can say, as like a work in progress kind of thing. Definitely, you do have resource manager available across the PDBs, and there is an option which is called the performance profiles available again from 12.2. The performance profile is something which is sort of like you can use to manage this kind of requirement. So like in the previous versions, you basically will create one resource plan which is going to manage the CPU across the CDB, and that means you need to have a separate plan available for a PDB, which possibly can actually not be very good thing. But it is possible from 12.2 that you can define a profile kind of thing, performance profile kind of thing, and you can actually set it up for a PDB so that you can limit the utilization of CPU in that particular PDB. But it is an option which is going to be there in 12.2, not in 12.1. Without having any kind of such option available, definitely the performance is going to be impacted, and you don't really have any control. The utilization limit, which is a parameter which is going to be there for this management, is going to be available from 12.2 in the form of performance profiles. So 12.2, this is going to be sort of like solved, but not in 12.1 or in 12.1.1.
And I believe this is going to be same if we have multiple non-multi-tenant databases running on a single server.
Yeah. Yes, of course.
Okay. Okay, so let's move on to the second question, and it is from Krishna again. So he says, like, is it possible to generate AWR reports individually for each of the PDBs?
See, yes or no. There is no specific report which is created as far as I know for PDBs explicitly. So there is no such thing like AWR PDB.SQL kind of thing. But you can definitely run that AWR report while connecting to the particular PDB as its user, or you have the consolidated report available from the CDB. As per the answer, no, there is no specific AWR report available at the moment for PDBs. You can connect to the PDB, run the report, or you can connect to the CDB and run the report. That's pretty much about it.
Okay, so I hope Krishna has got the answer, and he has just mentioned a comment for you, Aman, appreciating that it was a nice presentation.
Okay, thanks a lot, Krishna. Appreciate that. Thanks for joining the presentation as well.
Okay, so I have another question coming from Saurav, and the
Mhm.
question is, can PDBs in a CDB be configured differently? Like one PDB is in archive log mode and the another is in no archive log mode. Also, can PDB has its data files in local mount point and another in ASM?
The first thing is PDBs are going to share the log files, from the CDB. So it is not possible that you can have a PDB working as a non-archive log mode and CDB working in archive log mode, or vice versa, because PDBs do not have read log files available to them. So whatever the CDB will have, that's what PDBs have to be sharing. So in case a CDB is going to be in the archive log mode, a PDB has to be in the archive log mode. There is no such kind of differentiation possible across CDB or PDB. I hope that answers the first part.
Yes, Aman. And the
Right.
second
Now,
part
the
is
second one, PDB has data files in the local, storage, and another PDB in the ASM storage. Though I've not tested it out, I believe it should be fine because as long as the storage is available to the particular, PDB for access, it should be okay. But I will not be able to confirm the answer because I have not actually done it myself.
okay.
As long as the storage is available, as long as the ASM accessibility is there to the PDB, I don't think there is a problem. But I don't even think that's going to be a right thing because now you have to manage two separate locations for the backup. But that's a different, I think, different topic of discussion.
Okay. So I hope that answers that. So we have next question coming from Krishna, and he says like, is it recommended to maintain OLAP and OLTP in same container DBs?
Um yes or no depends actually, on the licensing part actually. But the answer is it's going to be much better if you create two separate containers which are going to be for specific purposes. So if you want to manage like a read-only environment, a pretty much read-only environment, it is better to have it in a separate CDB, and a pure OLTP environment better to be managed in a separate CDB. It's really not going to be a good idea to mix them together because the configuration profiles, the configuration chains are actually going to be different across them. So I think it would be much better to have two different CDBs or multiple different CDBs for different set of environments, and not just for environments, even for the storage. For example, like if you're going to be having a slow storage, I think it's better to have the CDB using the storage separately created from another CDB, which is going to be accessible to a much faster storage.
Okay. So yeah, means for this it depends like how you want,
Yeah,
right?
yeah. I mean,
If your
it all.
system allows, if your system allows, means on a same storage or in the same CDB, it's well and good. Otherwise, the recommended way would be to have it in a
Have
separate.
it separately. Yes, yes, of course.
Okay, so let's move on to the next question, and that's coming from Saurav. He says like, can we upgrade 11 to a 4 DB to 12c PDB and plug it in an existing CDB? I believe you have answered that in the presentation, but still,
Yes,
I would say you can go ahead.
I think we have answered the question in this way that a direct upgrade to a container database is not really going to be possible. So if you got 11.204, you need to upgrade to 12.1, which is going to be non CDB, and then you have to plug that non CDB as a pluggable into a 12.1 CDB. So that is something which is going to be doing the job. It's not possible to have a direct conversion possible of a non-CDB 11.204 to a CDB 12.1.
So yeah, means anyhow, means there is still a way, a workaround to achieve this sort of. So I believe if you are planning to do that, you should be able to do that. Not
There are.
in a straight way that sort of you have mentioned, but in a way like that. That's as Aman said, we have to upgrade a standalone database to a standalone one, and then upgrade means plug that into an existing CDB. Okay, so that's okay. So we have one more question, and that's coming from Mahesh. He says like, can we use different port? When they say port, means it should be a TCP port, like to connect to a PDB, and different port to CDB. Means
What do you mean?
can we have a different ports? You can say listener ports configured for PDB and CDBs.
No, I don't understand actually. What do we mean by port over here? Are we talking about listener port or what kind
Yes,
of port?
yes. So it must be a listener port.
Um. Well, I don't see there's a problem actually, but I don't know. It doesn't sound like a big trouble that we should not be able to use it. I don't see there is a problem in that, but I don't see any reason to do that. To be honest, I will pass this question. I'll just test it out and
Only
let
thing
you
that
know.
we may need to check would be Aman, if the
Connectivity.
no means if the PDBs have a local underscore listener parameter available to them locally.
Yeah, I think so. It should be available. I believe it should be available.
Yep. So yeah, if it is there, then it should be able to. They should be able to connect.
Yeah, yeah, yeah. But I think we need to test it out and come back to to the question, to the
Yes.
guy who is asking the question. Mahesh, I
Yep.
think you
So
said, right?
yes, it's Mahesh.
So probably we can have the ID of Mahesh and then we can pass on the answer probably in a day or two.
Sure. One more thing that we can do is we can post this question over the Facebook page that we have, and probably we'll answer the question over there.
Yeah, sure. We will
So
do that. We'll
the
do that.
other
Maybe.
audience which are not able to connect to the webinar for any reason, they would be able to get to the question at least.
Absolutely, absolutely.
Okay. So yeah, so there are certain appreciations coming in. Thanks, Aman. This was a great presentation.
Thank you.
Then Vikas Chaudhary is saying very good session, Aman.
Thanks,
Krishna is
Vikas.
saying nice presentation.
Thanks, Krishna.
So yeah, so overall we are getting good response and appreciation for the presentations that we have today.
All right.
And yeah, that's it that we all have for today. And what I have to say to the audience is, if you haven't liked our Facebook page yet, please go ahead and like the Facebook page. You will be getting all the updates there.
And
Then
our
we have
YouTube.
our YouTube channel.
Yeah.
So just subscribe to the channel. So anytime we are posting a live webinar, a live video, or you know, uh, any video we are posting up there, you would be getting the notifications, and you can even check our old webinar videos there. So those would be helpful to you. And I sincerely feel that today's webinar was good and helpful to you, and will help you in your day-to-day work. And thanks for spending our time on your weekend and spending a couple of hours with us. It was really nice. And thanks again from the AIOUG North India chapter team. We'll meet you soon with our next event and webinar for sure. Thanks a lot. Thanks, Aman.
Thanks, Nareet, and thanks everyone who has joined. And hope to see you guys very soon, sometime.
Okay, so have a nice day ahead. Thank you.
Thank you.